lesson. Last lesson. Yes.
We learned about volume of prison.
Volume over?
Prison.
Volume over prison. And what did we deal with in that volume of our prison? Which prison did you deal with? Yes? Triangle. And how did we see the volume of this triangular prison? How did we see that the volume of this triangular prison? How can we get the volume of that triangular prison? Yes.
Volume of a prison is equal to cross-sectional area.
Cross-sectional area.
Multiplied by height.
Multiplied by height. And which is our cross-section part? In this
Triangle.
The triangle part. So the area of the triangle, which is area of a triangle, how do you get it? Half base times height. So if you see that the volume is cross-section area times height, so we have the base area, which is the triangle part, and you have the height. So how do we get the volume of this? If you apply this formula, what do you get? Anyone? Yes?
It is the area of the triangle, base times height.
Yes?
Times the height.
Times the?
Height.
Height. Exactly. So today, I want us to deal with volume of cylinder. Anyone who knows how a cylinder looks like? How does a cylinder look like? Anyone with the clue of how cylinder looks like? Yes? Curved surface. Circular ends. Exactly. Or anyone with another view of how the cylinder looks like? So here is our cylinder. What can you see? What can you see? Yes?
There is a circular end B.
Circular end B. Circular end A. And the what? The curved surface. So this is how our cylinder looks like. Is this how our cylinder looks like? My students, is this how our cylinder looks like? Yes. And we say that from our previous lesson, the volume of a prism, any prism, I think you know the types of prisms. We have the triangular ones, the square ones, the cylindrical ones, and so on. So we say that the volume is the cross-section area. Volume equals cross-section area times. So which is our cross-section area or cross-section part? Which is our cross-section part? From this, from our diagram, which is our cross-section part? Yes? Circular. So it's a circle. And how do you get the area, cross-section area of this part? The CA of this part. How do you get the area of our circle? Anyone? Yes? Pi r squared. Pi r squared. Okay. Where's our height? Our height. Who can say the height? Yes?
Is that the distance between the two circular ends?
The distance between this distance is the height. So, to get the volume now, what is the volume of getting cylinder? Yes?
It will be the cross-section area, which is pi r squared
Pi r squared
times the height.
times the height. Good. So let's say that we have our radius to be 7 centimeters, the height to be the 10 centimeters. How can we get the volume of this? And you take pi to be 22/7. How can we get volume of this? I want you to tell me, how can we get volume of this figure? Anyone to guide me? Yes?
It will be pi 22/7
22/7
times radius
times the radius, which is
7 times 7
7 times 7 times
times the height
which is, how many times does 7 go to 7? 1. So 22 times 7,
154.
154 times 10.
140.
So you get 154. Is it? Centimeter cubic. Okay. Anyone to come and do this? Let's say that you have been given the diameter to be 7 centimeters and the height to be of a cylinder to be, let's say, 20 centimeters. Then you take pi to be 22/7. Anyone to find volume of these dimensions of a cylinder? Yes? And as he does workout, I want to see whether you get the same answer. Workout. What do you get?
22 multiplied by 0.5.
The answer?
It is 770
770 centimeter
cubic.
Good. Is he correct?
Yes.
Yes. So, I think from there you've understood that part. So, I want us to look at volume of getting material which is used to make a pipe. Do you know what a pipe looks like?
Yes.
How does it look like?
It is hollow.
It is hollow.
Yes, service.
Service. So this is how a pipe looks like. Pipe. This is how a pipe looks like. So I want us to get the material. This material, the whitish part, which was used to make this pipe. So this is how our pipe looks like. Is this how it looks like? Yes. So I want us to get the volume of this material, the shaded part, the white part which you've seen from the sample which we have for the pipe. So to get the volume of this material, how many cylinders are in this figure? Yes?
2 cylinders.
2 cylinders. We have which one and which one?
The smaller one.
The smaller one.
And the bigger one, which is the
And the bigger one. So we have this cylinder, the smaller one, as he has said. And we have the larger one, which is the external part. So let's take our larger radius of the external part to be the larger R, and the part which is the internal part to be the small r. We have the height, and from this, how does the height of the internal one and the external relate? How do they relate? Yes? They are the same. So, this height is the same as the external height. So, how do we get the volume of this material used to make that pipe? Anyone with a clue? Yes?
The volume of the bigger cylinder and the volume of the smaller cylinder.
So we get by the volume of the larger part, which is pi squared times, subtract what?
By R squared.
Pi,
R,
which are
smaller r.
small one, times the height. So this is the formula. So if you be given the dimensions of the larger r to be, let's say, 7 centimeters, and the pi to be 22/7, then the thickness to be, let's say, 3 centimeters. Then we have the height, which is 20 centimeters. Are you able to get the volume of the material used to make that pipe? Yes. Which one? How do we get it? How do we get it? Yes?
We first need to identify the smaller radius.
The smaller radius. How do we get it?
We subtract the thickness from the larger radius.
Thickness?
From the larger radius.
So what is the larger r? 7 minus thickness? 3 centimeters. What do you get?
4 centimeters.
4 centimeters. So how do we get that thickness, that material? The volume of that material. How do we get it? Yes?
We substitute in the formula.
Substitute in this formula. We have the larger r, the smaller r, and we have been given the height. So here we go. We have the pi, which is 22/7 times, which is the larger r, 7 times 20. This one, subtract what? Times what?
4.
Times 4 times 4 times 20. What do you get? What do you get? I want to see everyone, each of you working from a book. Don't wait for your friend to just shout the answer. What do you get? What?
The larger one is 3,008. 38.
30 minus the smaller one?
1005.
100.
5.7149.
Yes. So what's the difference from which you get from 3080 minus the nini?
2074.28.
Excuse me. Yes. 20?
74.
2074.28
.28
what? Cows, goats,
centimeter cube.
centimeter cube. Good. So today we've seen the formula for this cylinder, which is yes, pi r squared height, and the formula for getting the thickness of the thickness or the material which is used to make a pipe. How do you get it? Yes.
Is the volume of the cylinder using the bigger radius,
Uh-huh.
which is the bigger cylinder,
Yes.
minus the volume using the smaller radius, which is the smaller cylinder.
Good. Okay. Exercise. Go to your books, page 110. Do question 1, 3, and 5. Pen. Next lesson. Read on volume of pyramid. Please be careful and read. Thank you.